there. Let's turn all of this into an object. It's going to replace all this with spherical coordinates. Theta is relative to the x-axis. This is phi. To do theta first, I guess. Hey, toasting. Rectangle cons reference. No, I didn't. geometry. Instant distraction. What was I doing? Distracted, I mean. Geometry. We pass the geometry to sliders and I store it in the geometry. Yeah, well, maybe I shouldn't. I just want to... Oh, I still have that in my... I don't have it anymore. Totally lost my fake plots. Okay, that must be past the geometry and some empty style. Instead of the geometry, I need a fake plot. Let's create that fake plot first from a geometry and an empty style. What the hell? Why should that suddenly be necessary? Something else must be wrong. Okay, I get that one. You get that one, but what is its problem? Can I not do this? Can I not do this there or something? Okay, let's put it in the constructor then. I don't need to do this. Well, that was the problem. It doesn't know what this is. No, it's not actually. Sorry. It just compiles now. Create slider returns a slider. Yep, so it does. Oh, it's a plot slider. God, no. Oh, right. Yeah, I get it. Oh. Yeah. No. Ugh. I'm just gonna do I can declare here slider alpha here, return it and then store that on the stack. But well, let's just do sliders dot value 0. The first slider that was added. Yeah, I mean, normally you would return a handle cache. I could even return a double reference, maybe, if value is a reference. Sliders value is not return a reference. Nope. I really have to call value. Yeah, what to do? Oh, let's just add it. Oh, that's why it only did one. Okay, I could return a lambda that I can evaluate to the thing. In that case, I don't even have to do this. I would still have to call the lambda. I think I will do that. Let's just remove the handle. Substitute underscore handle of nothing. Let's not do this. This was called offset value. So add, now you should return a lambda. Wonder if that works. Well, it compiles and it links. Therefore, you know it will work. Bang! Doesn't entirely fit on my window though. Let's move this thing up. I have space here. Oh, this must be a little bit more space here. I could make my window larger. Probably the same thing to do. Next row plus slide offset Y. Slide offset Y, slide height plus 50. It's not enough. Let's make it 70. Would that be too much? Let's make this 350. Let's move it up a little bit actually. 80th, but who came up with that number? Awesome. Yep. Let's go through pi, 2 pi, 2 pi, 1 pi. Adding sliders are made easy, as it were. I kind of need a coordinate transformation here. I mean, that would make things a little bit easier. my hyperplane is three-dimensional, isn't it? How does it know that it is three-dimensional? I'll have an N. Yeah, this is n minus one dimensional, but we are working in one higher dimension apparently. Which makes sense, otherwise I wouldn't call it a plane. I think I need a coordinate transformation from the hyperplane to, well, the underlying 3D thing. So I could have the hyperplane return, let's say, a 3D vector, right? Hello, Scholar's Corner. I have no idea what that is, but I just want to lose one dimension, damn it. Well, it's not that difficult, I think. I just lose, well, we want to lose the normal direction. But yeah, but then what to do with the rest? I can just smash it. Doesn't explain whatsoever where the X, Y, and Z coordinates are. Okay, so we have a four-dimensional space, and in the four-dimensional space we have an absolutely arbitrary, well, whatever, unit, normal vector. And I want to return coordinates that somehow got rid of the dimension along the normal vector. Let's think about the one-dimensional arrow first, maybe. So say I have a three-dimensional space, yeah, and an arbitrary vector in there, and I want to compress everything into the plane. So any point can be projected into a plane perpendicular to this this normal vector. Then where are the x and the y axis inside that plane? Now, if my normal vector would be just 0, 0, 1, that pointing in the positive z direction, then the most natural way would be just drop the z coordinate. So if I input x, y, and z, then my output should be just x and y. However, if the normal points in the positive y direction, I have to drop the y coordinate. Now what if it points somewhere halfway? Let's say my normal points exactly halfway the x and the y, positive x and y direction. Then most natural thing to do is leave the z alone and combine x and y into something else. I need a drawing. We still have a I still have something open here. It's such a beautiful picture. I don't want to change it. Oh well. New? Nah. Well, this is, we could use this as an example, I suppose. So let's say the normal of the yellow hexagon here is pointing to the up left. No, not clear at all. Okay. Oh, like that. Okay, so you have the usual x and oh yeah, I don't have a room for this, man. Should start over. New. Isometric. So, okay, we have an x coordinate. What is this? It's filling stuff. I think I don't want to fill at all. Maybe do it like that. Oh, God. Why? Why is this thing closed? No, it is not. Okay, let's call this X, Y, and Z. And I'm going to, let's say, we have a line. I'll have a normal vector just in the XY coordinates. In the XY plane, I mean. like that. That's a vector. Just think of a little arrow here. Yeah, I think I got it. Haha, no, not really. But that one thing is for sure. If we have a point that is already in the plane, which plane? Well, okay, I can draw that as well. Green. Let's make a green plane. So if this is the normal vector, then our plane is perpendicular to it. So the plane is exactly hidden behind this thing. I'm purposely going to rotate this thing, I think. Let's move it a little bit, like so. So perpendicular to that is something like this, I guess. But then in both directions. I'll actually have a line here. And vertically, well, vertically it's still the same as the z-axis, right? I just want to move one point here. Sorry, thank you very much. No? Oh, yes. So this is a three-dimensional thing. Blue is three-dimensional. This is the x-coordinate, this is the y-coordinate, this is the z-coordinate. This is a unit vector in the xy plane. And that is the normal vector of the green plane. Yes, so because it's in the xy plane, the z-axis lays and is in from the origin, so the z-axis is laying in the green plane, and this line is in the xy plane and perpendicular to the normal. And then I think my most important insight here is that if we have a point that is already in the plane, I need to be able to draw a point now. Let's make this pencil. For example, if we have this point here on the x-axis, then the projection of that so this point is three-dimensional, and it has coordinates 0, 0, comma, yeah, let's call it just z. Nah, that may be a bit too confusing actually. Let's call it alpha. I probably should have done that in blue, but okay. Then the projection of this point is, well, it's already in the plane, so it stays in the plane. But it must have two coordinates, and I think that the only reasonable way to do this is by returning having one axis equal to the z-axis. So yeah, I mean, you could call this x and that y, or the other way around. I think that doesn't make much difference. But one of them has to be alpha, and the other one is then 0. That's the only way to do it. Likewise, if you have another point in the plane on this axis, so I say here, then we can conclude that, well, from this choice, that the first argument, let's make it a little bit darker here, to the, well, darker, okay, nobody can see this. Now the first argument here, which was 0 here, must be this distance. So let's say this distance in the three-dimensional space, d, signed distance, that's going to be here, because, yeah, seems logical. And then we have a 0 here because the y-axis now is not there. And the d then means that this d is the square root of x squared plus y squared, where this is x. That is really shitty color. Why is it so light? Give me something dark. That was the problem. I want something dark, and I want something more fat. It's too thin. Oh, line width here. Maybe it was 4 point or something. Now we're talking a dark X. And here we have a Y. And while I'm at it, this was Z. Then if we have a normal, this is my unit normal. So unit, give it a cap. Length is 1. Then a point, this point here, well, any point actually, is going to be projected as, if n is in the xy plane, then my projection is going to be, let's do that then in the darker green. It should be readable now. If I go down, it gets darker. What a nonsense. So any point in this plane, for example, I don't know, this point here, I'm gonna call this y and this x. And this point has coordinates in the 3D space as well, x, y, z. And in the green thing, it is the square root of, right. I think this is then the only natural choice, because, like I said, if we have a point that is on the z-axis, that means x and y are 0, and z is well, some value. Well, this is how I did draw it. The y coordinate is equal to the z coordinate. It just point in the same direction. So that the y coordinate of this point in the green coordinate system has z here. And of course you could scale it, but yeah, as y, you know, what scale? 1 is the most natural choice for the scale factor. You can still swap them. Likewise, you can mirror the whole thing, put a minus in front of it, but it's the same as scaling. So I think this is a good choice. If there's any, you have to make a choice, and I'm just going to put z here. And then a point in the xy plane, like this point, we want to have, let's say, in terms of distance, if you just rotate around n, this point, it gets there. So, if this distance is the same as that distance, then you want to get the same value here. So you just, I know, but this coordinate here must be the length in the 3D space that we have here, which is, well, the square root of x squared plus y squared. And now, having this inside, can I generalize it to an arbitrary n? The weird thing is here that n is already pretty damn arbitrary in terms of x and y. So apparently it's not that important. What is important is that we picked the y coordinate to be a z, and then the remaining part is just the length of whatever is remaining. Yeah. Okay, so let's say we now have can I select stuff? How do I add something? Can only rotate. Oh, this is select. Looks very much like a rectangle thing, not an object select. This also select. Aha. Yeah, now it's gonna bring in a lot. I can delete it again, I suppose. I'm trying to draw something. I'm trying to figure out a way to represent points that are projected onto a plane in a two-dimensional coordinate. So you have three x, y, and z in the three-dimensional space. I can project that onto a plane. And then the question is, what do I return? Now, if the normal of the plane lays in the xy plane, then I think this is a very reasonable thing to return. But what to do if it is more arbitrary? Somehow it will only want to select the blue stuff. Delete. lots and lots of little dots. Can I get that? No, that immediately moves. That's stupid. That's not select. Do not select. No, do just not select. Okay, how about this? And now unselect this. No, not possible. Not the same thing, but that seems to work. Okay, arbitrary n, it's pointed up there. A line. Can we do dotted lines? Why is this 4.13 suddenly? Normal, yeah, that's something else. Surely we can do normal lines, dotted lines. Okay, no dotted lines. Let's do then line says alpha or something, or just nah, way lighter. Guess it doesn't really matter how you point a normal, there is always going to be a line in the XY plane. For example, in this case, I think, no, this, imagine this line is in the XY plane, then it's going to be something like this. Pretty much, I think. Move, just draw another line. Okay, suddenly you can't draw lines anymore. Dude. Do not move point. No. It only wants to move points now. There is no way I can draw another line. Not even for, oh, now we can. Okay, now I want to move points. Yes, move point. Yeah, there we are. And then, of course, we have another. Does not want me to draw lines anymore. Oh, I have to click here. Ah, I have to click there. Okay, another one. This one is perpendicular to the green line and the red line. Let's go down as well. Yeah. We can find these lines, right? At least to a certain extent, we can find those lines. This one still more or less looks like the Z line, so it's like scaled a little bit down, but not that much. I mean, why would I pick these two lines? That is a good question. Why would I pick a line that lays in the XY plane? Here it is obvious, because one is Z, so the other one must be in the, is perpendicular to the Z, so the other one must lay in the XY plane. But here we have more choice. I guess it depends on the angle with the Z-axis. If that angle becomes too small between the normal and the Z-axis, or too large where it rotates away, then at some point you just have to switch to another plane. That seems to be yeah, logical. The question is more than, what if we just somewhere halfway? It's already actually pretty halfway, I must say. So what was another choice that we had here? Not picking a line in the XY plane, but picking a line in, say, the XZ plane. Or anything actually. Now we picked these two lines, you can just rotate the whole thing around the normal here, of course. So, and then you get absolutely arbitrary axis. Oh, but okay. Let's say this, the angle that this thing makes, it's yeah, it's pretty big actually. It's this. There's a line here. And then we have an angle here. Pretty sure that should be the same angle as between this line and the z-axis now. Oh, it closed this. Oh, finally I have my arc. I was looking for that arc. I'm gonna discuss this with the AI, I think, as a rubber duck. Just drawing doesn't cut it, not yet anyway. I think we just have a free choice. I'm not good with free choices, I like deterministic stuff. Might be related a little bit to this. Let's add to this discussion. Hello? Not entirely. Because that would be always positive. I need negative values as well. How to get a sign? Is that correct? How do you project something? It is length times normal. So we subtract on length times a normal with a height along. The normal is okay. What we have b is 0, and our normal is 1. A unit normal. So this is normal dot a divided by 1. So normal dot a times the normal again. Yeah, of course, otherwise it's a scalar. So this dot product is a scalar. I have to multiply this with the n dot and the normal again. Just subtract it. No, I did it the other way around. It doesn't matter, right? Oops. Yeah, the last sign I don't care, so we just do let's say v is uxn view is already known. Not sure about the sign, but you should use the opposite. It's for the other way around. Use minus v cap dot x, I mean, in. Yeah, it's we have come quite far, I think, humanity. While I was typing this, I was 100% sure that the AI would understand what I was saying. There's no doubt in my mind that it could just follow exactly what I'm saying here. It's a completely different thing that then it will come up with a beautiful way to solve the problem, but it's already quite impressive that we really have an artificial intelligence that just recognizes what you say here. It did come up with flipping points. Yeah, I want a canonical 2D coordinate system on the plane capital Pi. An x, what is this x? As a vector, I guess. Okay, the plane is defined by x, where the dot product with a normal, a unit normal n is 0. Yep. So that means that the plane goes through the origin. The offset here is absolutely not interesting. Any possible offset. So that a projected point Q minus n dot P times n can be written as Q equals QUU plus QVV with QV orthonormal in pi. And you would like this to agree with obvious axis choices in special cases. Agree with, yeah. That is the perfect mathematical summary of what I just typed. That's what I mean. It's just 100% got what I asked. A principled and practical construction. Pick as an anchor axis the standard basis vector that is least aligned with n. Or the smallest dot product. Yeah, it's stepped from x, y, and z cap to EI, which is more common, I guess, in literature. Project that axis into the plane and orthonormalize. So we choose the minimum E, such which is the element of the set, so it's either the x, y, or the z unit vector, where the absolute value of the dot product with a normal vector is the minimum of the absolute values of the x, y, or z coordinate of the normal vector, let me think. For example, if nz is 0, then the normal vector lays in the xy plane. Therefore, we are looking for the E such that the dot product with n equals 0, because this then is 0. Which, of course, would be the z-axis then, if n is in the xy plane. So that would be E2. Suppose it starts numbering at 0. Okay, define U is E min minus n dot E min n divided by the length of that. And V to be n cross U. So that UVN is right-handed and orthonormal. A pretty cool choice, yeah. Yeah. Very, very good. I like this very much. So if the normal points in the z direction, then u and v just become x and y. Which is super logical. But if n points in, let's say the x direction, what would happen then? X direction. Let's go. If you think about a cork screwdriver, and you want to point this or the screwdriver is also rotating the same way. You point the screwdriver in the direction of the x-axis. That would be the normal then. Then you rotate. Then you rotate from. I think I did draw it correctly here. No. This is the normal way you rotate. Is that true? Yeah. I mean, if you lift the y-axis up and you move this whole thing such that x points horizontally to the right and y points up, then z should point out of the screen. So I did it correctly. Which means that you rotate in order to go up. So you want to rotate the cork screwdriver out of the bottle. You have to rotate anti-clockwise. So you rotate x to y and then you go up. Yeah. That means that x cross y equals z. So if now our normal vector points in the positive x direction and you want to go in that direction with the cork screwdriver, you have to rotate like, well, do it in your mind, like this, which means you have to rotate y to z. Yeah, if your cork screwdriver is in the direction of x, you have to rotate y. You have to rotate this way from y to z, in order to get into the bottle, into the x direction. And that then dictates more or less which of these two is x and which is y. Namely, if x now is the z thing, then so you have to move x to z, then y ends up here and z ends up there. So the y-axis becomes the x-axis and the z-axis becomes the y-axis. So if you rotate from y to z, then y is the x-axis and z is the y-axis, which is a very natural choice. Even better than just keeping the y-axis the same. You don't need to form a queue, since u and v are orthogonal to the normal vector already. So yeah, that projects it away anyway. Well, this matches your natural cases. Now, let's assume the normal vector points in the z direction. So our plane is the xy plane. Then the least aligned axis is ex. Okay, where does that come from? I mean, I don't see the x here. I mean, that's x and y are totally symmetrical, so why would it pick x? Let's verify that with the formula we had here. Both I mean, the dot product between, let's call this EZ. Dot product with EX and EZ is 0, and the dot product with EY and EZ is 0. So you can pick either. Anyway, this is 0. Therefore, well, it's either that one or that one. So it's at the least aligned axis. No, it's EX or EY. But that doesn't matter, because I guess we should get this regardless. Or not. This was 0, so we don't subtract anything. So whatever you pick for E min is gonna become U. I don't know why it picks EX here. I'll have to ask. Well, point out that that is not logical. U is minus EZ. Yeah, because it's the y-axis. Let's check that. So now the normal vector points in the y direction. Which means that if you want our screwdriver or cork screwdriver to go in that direction, you have to rotate that way. Which means that z becomes the x-axis and x becomes the y-axis. But it picked x as the x-axis, because apparently that doesn't really make much difference as long as you still rotate through to the y-axis. And then the x is the x-axis, and therefore y is that must be here, because you rotate from x to y. So then the y-axis becomes minus the z-axis. That thing also exists. Hey. So yeah, that's correct. If the normal vector lays in the xy plane, the least aligned axis is EZ, since that is 0. Yep, that's the only one that is 0 now. For non-zero nx and ny anyway. Though, therefore we pick U is EZ, and V then becomes a cross product between n and EZ, so one coordinate is exactly the original Z as desired. You can't make a globally continuous choice of U over all n element of S squared, the hairy ball theorem. Oh, papers have been written. Any rule has seams. For the anchor rule above, the frame switches when the chosen least aligned axis changes. E on the great circles. Die break deterministically. G prefer x over z over x over y, I mean, and y over z to keep it well defined. If you want to reduce jitter near seams, add hysteresis. Only switch the anchor when, say, nu is smaller by a margin of delta is 0.02. An alternative that is smooth except on seam. Rotate the world so that z goes to n. Rodriguez. So those guys, they always did stuff before I did it. Annoying. Before the AI did it, I mean. Let's see, is ez dot n is nz. A is ez cross n. Yeah, this is what I already do, actually. But I have an additional problem, because this discussion is about 3 dimensions and 2 dimensions. But my actual problem is to go from 4 dimensions to 3 dimensions to 2 dimensions. So I can go using the, well, Rodriguez then from 4 dimensions to 3 dimensions. And then I still have to go to 2 dimensions. No, actually, no, never mind. I defined that as well already. Yeah, no, never mind. I was solving a sub-problem, but it is in a hyperspace. So I have a hypercube and a hyperplane, and then we want to, we have a hyperspace and a hyperplane. And then we want to go from the hyperspace coordinates to 1 dimension less. And then it's definitely an obvious choice to rotate one of the axes away along the normal. But what about the rest, you know? So not a problem here. It's just always larger than 0. Okay, I have a lot to think about, so I'm going to the fitness, which I have to do as well today, and then I'll think about it while I fitness. Yeah, something to do. One problem: I have to count as well at the same time. Not sure if I can do that. That's a challenge. Think about multidimensional spaces and counting at the same time. I'm a man, so can't do that. Well,